Hello everyone and welcome back. I wanted to record this video to show the final sim and talk about a few more things that hopefully will help you guys to try some new ideas. Now this sim took about 1 hour and a half for 110 frames, and the last frame has it's 374, 332 and 684, so it's pretty high res, 86 million voxels. And this this is the original sim, and then I rotated it to see how it looks if we changed it to move upward. I didn't change the sim, this is just rotating it as a post process. Now looking at the curvature result, you can see that it's not picking up any of the details here, and we have to go back and fix the map. We can take this frame and then do it in SOPs or in DOPs to make sure that it's working nicely. Also, the density in the sim is a little bit low, and capturing the curvature from that low density can be tricky. That's why I mentioned that it's always better to have the actual density values within the sim rather than relying on multiplying them afterward. Now, I think everything is working. I see all the characteristics that I'm looking for, primarily the breaking up the mushroom and the recursive splitting of the shapes. So if you look here, you can see it starts off with, and then with a simple shape, and then it starts recursively splitting that. So you can see the actual pattern here, and that section is going to get split more and more and more until it hits the smallest value that we've defined by the voxel size. Now, one thing that I like to tweak, obviously, is the dissipation level. I think it's very, very extreme, but the mask and all is working. It's not affecting the front part. It's only affecting the part that is not moving in this direction. So that the masking is working nice. And yeah, I think we have a lot of interesting details. You can see at the beginning we have this part happening, and that's because the curvature has enough information to generate that at the beginning, but afterward it's only working here, which could be an interesting effect as well. Now please note that the fire here is not doing anything to the sim. Cool, so what I wanted to talk about now is show something about doing these previews. And if we go under, we can use the flipbook here, but we can also use something that will hopefully make it better and faster to render OpenGLs with Houdini. And if you hit tab under the out context, there is this OpenGL node, and it's basically a render that's going to use the OpenGL. It doesn't use this viewport. It's going to do something different, and it's generally faster because it doesn't have to display the value. It just stores it in the in a JPEG file or whatever extension. So basically, this is the default settings. I specify where it's going to save. I generally use a JPEG, apply 2.2 gamma here, and then it depends on the settings. For this one, I've set the depth to full HDR to capture all the nice details and transparency in the smoke. This is not really required, but you can try a few things. Anti-alias doesn't do anything with volume. Everything is this is controlled by the transparency, which is set to high, and then this guy. And that's pretty much it. Also here, so I left those to the default, and then I use the camera and hit render, and it starts generating the image to disk. Cool. So the other thing I wanted to talk about is with the noise pattern. Let me find that sphere. So for example, we have this sphere here, and I talked about the Worley noise, and we've used it to push the data in one direction. So you can see it here, it's pushing that. But we didn't generate anything to make it push forward and backward at the same time. It's only applying it along one specific direction because it's a black and white map. And let's actually preview the map. Let's take a look at this one. Yeah, this one is more clear. And you can see it's only positive values. There is no negative value. It's not going to push in the data. And the way we can add that is using this seed here. And let me create a random. I'm going to tell it to generate a random color, 3D color from the integer. And this basically a unique value per cell. So let me preview that instead. You can see now we're getting randomized color per cell. Now if we multiply this with this, we can get randomized color per cell. And what we can do is we can generate random values between 0 and 1. So 1D, you can see now we have black and white maps per cell. And we can say compare. We want to compare this guy, for example. If it's less than 0.5, we're going to multiply the result by -1, which is this. Multiply it by, sorry, this guy. We're going to multiply it by -1. Sorry. I'm going to do the comparison, and then the boolean needs to go into a two-way switch. This is the condition. If it's correct, if the result is less than, if the condition is met, we want to multiply the values by -1, and then if it's not, we want the original value. And this way, we're going to get a negative value, and you can see them here displaying as black. Now, what we can do is we can use this result to multiply it with the original black and white mask here. And we can use it with the amount, and let's connect that to the displacement. Let's turn this off, and now it's going to push in and out the data. Let's reduce this. Now I'm setting 20, only 10% to be negative, and then the rest is positive. Let's multiply this a bit to see the effect more clearly. Yeah, we need to go stronger here. I'm multiplying how far it goes in. And you can see now we're getting push in and push out using the Worley pattern, which could be which we can use to add more details to the sim instead of just pushing it in one direction. So this is one thing. The other thing I wanted to talk about, if I can find the sim part. Yeah, this one. So let me grab one volume from here and go to a frame where we don't have a lot of data, and let's use that for this example. Okay, so I'm going to convert that, and this is something we've done already, and we're going to do a volume vault to displace this. Now when we generated the vector, sorry, not this guy, I think I deleted that part, but basically what I'm looking for is the gradient, which we have, and then I want to generate the noise based on the gradient. So let me create a noise here, and let me delete these guys, and I'm gonna export the data, the noise result, as a val in the val vector, just to preview it here. So bind export. And this is just to preview the noise. And let's set it to a 3D vector. And let's go to visualize. Okay, let's select the velocity if we have it. Oh, we don't have velocity here. Okay, so let's do this. Let me rename the gradient and add another one, and add a vector field. So I'm going to take that and rename it from grad into color. We'll do a proper name now. Okay, let's merge that. And let's dive inside. We're gonna bind export it as a color information. And now we should see that show up here. Cool, so that's our information. And let me do this. Let me just export the gradient. Okay, cool. And I'm going to create a scatter node. I'll explain what I'm trying to do in a second. I'm going to scatter a lot of points, and I want to sample that gradient vector and display it in the viewport. So point VOP. Volume sample vector. We want to sample the second input, and the name is grad. And let's export that as a normal, and let's see it here. Let me normalize it. Cool. So now we have something. We have the gradient displayed. And what I want to do is, actually, I think this is better. So let me do, instead of using this vector, or instead of using the noise result as it is, we can actually use this, but I'll explain the idea. So instead of using this vector, we can compute the cross product of that. So let me run a cross product between the gradient. Let me use the normalized node. And let's take a look at this. So what's going to happen is, let me put down a switch and show the difference. So you can see how the vector is rotating. And what this is going to give us is basically swirls. Instead of having the noise go this way, for example, or this way, we're gonna compute a cross product that will make it that will create a perpendicular vector to that, basically. And we can also take this further by computing a cross product once more between the result and the newly created vector. And we can create all kinds of interesting directions that we can use. So that, and then that, yeah, that's correct. Let's try this. And we can create all kinds of interesting vectors. And what this allows us to do is, instead of using the gradient that is facing in the same direction, we can create a circular shape around each noise, and this can create more interesting details as well. So it's definitely one of the things I've done as well in other sims. And yeah, this is perfect. You can see it here. Let's connect this as a third one. So this is the original result. This is the second vector. You can see how it's swirling along this way. And then this is another option for the vector. You can see it, how it's going this way. So we can use this to generate more interesting vectors, and you can use this with masking as well, with the various masking techniques that we've looked at. And I think that's pretty much it. Thank you guys for watching, and see you next week. Bye bye.